So, hey everyone, hope you're all doing well. So, did you know that O3-mini from OpenAI is like the response of OpenAI towards the DeepSeek R1 reasoning models? And did you also know that O3-mini now supports multimodal inputs, meaning that you can also upload an image or you can also upload a text and you can get the response. So, what I did was I wanted to test the capabilities of O3 Mini on images, on how it understands and reason about images. And I have this 10 practical image challenge I usually do on vision language models. And I wanted to run this across O3 Mini. But what happened was I ran it across O3 Mini, but the performance was really poor. And there was also another model, o3-mini-high. Therefore, I was like, okay, why not we also try this image challenges with the o3-mini-high models, right? So today, that's what we're going to do. We're going to do the 10 practical image challenges on OpenAI's ChatGPT o3-mini-high models. Let's jump right in. So hey, I'm in ChatGPT now. The first thing I do is going to change this model to o3-mini-high, which is supposed to be great at coding and logic. Previously, we tried o3-mini, which is fast as advanced reasoning. So let me just change the model now. And the first image that I'm going to upload is going to be challenge number 1, spot the difference challenge. I'm going to prompt and tell that this image has 2 photos with spot the difference. Carefully check both the photos and try to spot the difference, right? So let me show the image and see what I mean. So this is an image from a Tamil magazine called Kumudam. So it usually comes with spot the difference challenges, used to come at least, and I've been testing this with various vision language models and image understanding models. So just to show what the differences are, let me show the next image here. So you can see that there's one difference here, one here, and then one here, and then one here, and one here. So you can find these 6 differences. So let's see if o3-mini is able to get that. Hi. Okay, it thought for 1 minute and 51 seconds. That's quite a long time. So let's see what it says. It says that below is one way to spot 6 changes between the top cartoon and bottom cartoon, so it's able to understand that. Pink car circle on the table, the number positions on the bird cage, stripes on the pink cloth, stripes on the green cloth, and the sign or text behind them, and small detail on man's shirt. Look for a shirt pocket or a seam in one panel that is missing. Sometimes a difference in his mustache shape or a button, but often in this pocket vanishes. So yeah, this is one thing which it probably got right. Let's see, pink circle on the table. Pink in the top picture, the pink disc near the lower edge of the table has a white center. In the bottom picture, it's a solid pink center, no white center. So let's see if that's true or not. So pink center, yeah, so this is pink, and then I don't know if this is what it's referring to. So if it is, then this is correct. Pink disc near the lower edge of the table has a white. In the bottom, it's drawn as a solid pink circle, no white center. I think it's telling something else. Number on or position of birds in the cage. In one panel, you can see 3 birds clustered a certain way. In the other panel, the number or arrangement of all birds is slightly different. Yeah, this seems to be not, in the right sense. Stripes on the pink cloth, top edge of the table. The top cartoon has a certain number of vertical lines on the pink cloth. In the bottom, one stripe is missing or either added. Yeah, this seems to be okay too, but we're talking about the pink cloth here, right? So it's not, maybe it's something else. And then the next one is stripes on the green cloth, middle of the table. Similarly, the green section of the table has a different count of thin black stripes. So I don't think this is what we are talking about. This is something else. Stripes on the green part of the table, unless it thinks that this is the green and this is the pink. So that's a different thing. So it's not This is not really what we're looking for. The sign or text behind them. In one picture, the sign hanging in the background appears to have two lines of writing. In the other, there seems to be three lines of writing. Small details on man's shirt. So this is the one which is actually, it got it completely right. Look for a shirt pocket or a seam in one panel that is missing or altered in the other. Sometimes a difference in the mustache shape or a button. So that's also kind of true. So mostly, most of the other things were not fully right, except for the mustache. So you can say maybe we just got 1 out of 6. All the others, like it seems, are not that, not that correct. It missed this, it missed this, it missed this one, and a few other ones as well. So I don't see any signboard here or text, so that's also not there. So let's go to the next challenge, and the next challenge is going to be on people, how we can deal with people. So I was lucky to kind of get a photo with two professors, Professor Gilbert Strang and also Professor Jeannie Golub at two different occasions. That's going to be like challenge number 2. I'm going to ask it like, how many peoples do you see in this image, and what do you think about it, right? So this is the image I'm talking about, and let's see how long it takes for this. So this is the image here. And let's see what it says. So this one was fast. I think it took only 8 seconds. It looks like there are two separate photos placed side by side. That is really good. It was able to recognize that. So they were taken in two different occasions. So I did place them side by side. So it says each photo has two people, so there are 4 individuals. So and it describes the other ones, and the photo of the right also describes perfectly. So that's great. So I want to ask them if it can recognize based on the context or clues I give. So I say that one of them is a professor who wrote the book Linear Algebra and its Applications, and the other is the one who wrote Matrix Computation. He's not alive anymore. So here's the interesting thing. What I'm going to do is, right now GPT search is not on. So let's see if it's able to find with GPT without GPT search. So it says that for 19 seconds it's not able to find. Let me try turning on searching the web, and let's see if it's able to get this information from the web. So reasoning, it still says it cannot help with that. Can you try? I guess. So I'm just trying to see if we can probe more, if we can do that. It's somehow maybe the guard is saying guessing authors. Okay, finally it does, right? And you can also see the reasoning kind of here. I wonder why it did not do it in the first run. So then it says clarifying author readership. So you can even see those steps here. That's very interesting. I'll take a stab at it based on the clues you provided. For the MIT professor associated with linear algebra, the most likely candidate is Gilbert Strang. That is absolutely right. And then for the author of Matrix Computation, who's no longer with us, that points to Jeannie H. Golub. He was a pioneering numerical analyst whose book Matrix Computations co-authored with Charles Van Loan. A foundational work in numerical linear algebra, is passed away in 2007. That is perfect. So this is amazing, right? You can see that when I did not search the web on, it was not able to kind of help. And when I was able to say that, okay, can you guess it based on the context and provide a little bit more, it's like putting the model more and more, it was able to kind of take a guess and do that. This is a nice finding, I would say. So that's really interesting. So I'll turn it off, and then I'm going to ask. So I want to see if it can identify me from these two photos. So you can see that this was taken in maybe 2007, 2006. This was probably later, maybe 2011 or so. And definitely I do look different in both these images. So I want to see if it can find that. So let's see. Based on a closer look at the facial features, left photo is a younger person, appears to have a mustache, has facial structure, seems angular, and so on. The right photo, younger person, clean shaven, no mustache, and his facial features, slightly different character. Okay, it's able to identify me because I'm wearing the California t-shirt, so it's able to do that. That's a good thing. Could they be the same person? While it's always possible that changes in grooming, like shaving a mustache or differences in photographic conditions, could account for some variation, the presence or absence of a mustache is fairly a strong visual cue. So it's saying that unless I intentionally change the look, which is kind of true, they suggest that they are not the same people, likely different people. Comparing the key facial features, especially the difference in facial hair and overall presentations. So it says that it's unlikely they're the same person. So the answer is not correct. But I like the fact that it was able to kind of at least reason out in this way. So that's interesting. So let's move on to challenge number three. So challenge number three is going to be on a very practical topic of recognizing people in surveillance and CCTV. So here's the CCTV image from my home. So what I do is, and I'm going to prompt and say that can you find the person reappearing in two different timestamps? So let me show the image in greater resolution. So you can see that this is a CCTV taken at two different timestamps, and there is a person here, right, in camera number 2, and the same person is appearing in camera number 5. And as a human, it's pretty easy for us to say that it's the same person based on, like, you could see some clear features and so on. But these are what is really interesting for to challenge the computers with. So let's see, like, if this is able to get that. It took 44 seconds. So let's see. Each camera shows a 2x4 grid. So it's not 2x4. It's, I think, 3x3, right? Clearest instance seen in labeled camera 3. Top row, third from left. You can see a person standing in roughly the same area in the camera's field of view. Other feeds do not show the same person. It says camera 3, camera 3. So the grid is 3x3. What I say? And you check again. So let me just show the grid again. So it's 1, 2, 3, 1, 2, 3, 1, 2, right? So it's definitely not 4x4. So again, 1, 2, 3, 1, 2, 3, 1, 2. So yeah, this one is left intentionally blank. There are only 8. So, okay, even though there are 9 slots, okay, this is correct. Only 8 of them are actual camera feed. This is really amazing. It's able to say that the 9th one is actually a system info on live camera. That's brilliant. I like this. Even if it gets it right or wrong, I like the fact that it's able to get this understanding. It's even placed this amazing camera 1, 2, 3, 4, 5, 6. Brilliant. Like closely comparing, and then it almost gets it, but it misses this one. The most unambiguous appearance of the same person are on 3 and 7. Unfortunately, it's supposed to be 2 and 5. So, but it seemed to miss there. But yeah, and it's saying wearing a light white shirt and same quarter salmon from same individual in a yard open near a building. Unfortunately, that's not true. It's a completely different one. But this is, yeah. So this is a kind of what I was expecting as what it would give us a JSON. So at least it tried, but it was really close. So I like this one. So let's go to the next challenge. So the next challenge is going to be from one of my favorite ones. This is about how can AI help as a tutor in like kind of helping out with reading lectures and so on. So before that, what I'll do is that I'll just show what the answer was. I was not sharing this tab earlier. So what I meant to say is that if you can see here, so it was able to say, so the grid is 3x3. Can you check again? Reason for 35 seconds. Analysis or reflection. You provided the two side-by-side screenshots of a CCTV monitor arranged in 3x3. So even though there are 9 slots, only 8 of them are actual camera feeds. That's correct. The 9th slot, the bottom right, seems to be a system info rather than a live camera. That's brilliant. So it's able to actually get that I'm not only 8 of them are actually camera. For example, like and this one is actually like system info feed. This is like brilliant kind of even if it gets the answer right or wrong, I'm happy that it's able to like understand this much of it. So labeling these 8 feeds from top left to bottom right. So it's gonna label these from this is also exactly what I wanted. Row 1, 1, 2, 3, 4, 5, 6, 7, 8, and then the system info. Brilliant. So now let's see if it can identify the person. So it says camera 3 and camera 7, which is unfortunately not right. It's supposed to be camera 2 and camera 5, but it seems to have gotten what I'm trying to look for. So it says light or white shirt and so on, and then the JSON also seems to be okay. indicates a person is visible. So yeah, so it's got 3 and 7, which is not right. But again, I like the fact that it was able to come this close as to understanding what I kind of wanted. So let's go to the next challenge. So the next challenge, we're in challenge number 4. So this is one of my favorite challenges, and then this is a screenshot of a lecture by Professor Hani Farid from UC Berkeley, and then here he's explaining the concept of linear regression in quadratic form, and he's actually putting up a code here. Before this, he taught the concept, a theory behind it. So what I would like to check is that if AI can actually the o3-mini-high model, can it kind of first understand the screenshot? Basically, it has to parse this information, extract the text in it, code from this, and then if it can kind of understand what concept is being taught, and if it can give more information about this, right? So this could be really useful in lots of scenarios when you're learning some concepts and so on. So let's see what it does. So reason for 44 seconds. So let's see what it does. Import numpy as numpy and so on. So this is unfortunate. So it missed the quadratic form. So once it misses this, whatever it's going to get it's completely not going to get it completely right. So it's also puts a lot of comments here. So that's very strange because some of the other models were getting this perfectly. For example, I tried the same with GPT 4.0 and 4.0, which is and this is getting it perfectly. You can see that it's able to get the quadratic form, and it gets the code inside correctly. Whereas o3-mini-high, not sure because if it is a mini model, so it has some constraints or something. So it's able to get the steepest descent, but any other things than that, it's going to be it's not able to completely get it because it misses some of the key concepts here. It's good that it was able to kind of explain it from the context a little bit, but basically missed some of the code from there. So that's unfortunate. So let's go to the next challenge. So the next challenge is supposed to be an easy one, but it's still practical case. So I once went to a store, and I was happy to find that store had an electronic waste bin. Basically, you could go and dispose your electronic waste, and if you have, and it also had a nice advertisement here. So I wanted to see how AI can process this kind of information. Most of the AI models did really well here, so I'm expecting this also to do so. The only reason for a few seconds, it's a promotional display and collection box for e-waste recycling. That is correct. So it's pretty fast here. So it was able to dispose your e-waste, and also the other advertisement information from it. So it basically got all the info, which is kind of true. So yeah, let's move to the next challenge. So the next challenge is going to be really interesting because this is a practical challenge again. So this is about how you go to restaurant menu cards and you would like to get a specific dish. If AI can help with getting specific dishes. So I'm going to say, can you list out all the dishes which are Jain and spicy? So what I mean by that is that so I am this is one of the restaurants that I usually go to. It's called Bangalore Tiffin House, and this has a interesting menu card, and you can see that this has markers called Jain food here, and it also has markers called spicy food. So the chili one is marked by spicy and the other one is marked by Jain. So I want AI to get the dishes if it's both Jain and spicy. So it only has about 5 of them, 1, 2, 3, 4, 5: bel puri, sev puri, dahi sandwich, and a few ones, and this one. So let's see if we can get this. As a human, we are able to very quickly process this. Okay, this is unfortunate again. It's very similar to what O3 was also saying. From the menu, there isn't a separate Jain section or any item explicitly labeled as Jain. That is completely false, right? Because we just saw that the menu card did have something which was so it's got it, and then it says okay, what could be Jain. So yeah, those are true, but it's got the main stuff wrong. So tips when ordering Jane plus spicy, and then it's saying what can you order, and then things like that. But again, that's not what we want. We want from the menu card which one is actually like Jane. So it's kind of um, it's gotten it wrong. So let me move to the next challenge. The next challenge is going to be on. This is going to be easy. So I have like a paste, a tamarind paste. This is for a South Indian dish. I'm going to just say describe this photo and what is it used for, kind of a thing. So let's see. So this is called pulikacha, which is used for like tamarind dishes. So this usually AI models get this very easily. It only took 4 seconds. A plastic jar with a green lid and yellow. It says pulikacha rice mix, grand sweets. So it says for puliodarai or pulihora, can mix spoons of this paste with quick, freshly cooked rice to create a tangy dish. So yeah, we got it perfectly right, and no surprise there. So this was a great one. So let me move to the next challenge. The next challenge is going to be an interesting one. Challenge number 8, I think. So this one is how can AI recognize events from a religious calendar? By that, what I mean is that apart from normal calendars, you can also have a specific tailor-made like religious calendar. So I tried this for the previous model. This is from 2024, so I want to try it again for the same one. So let me show an example of what I mean here. So this is a religious calendar, and it has events pertaining to some religious function. So I wanted to see if on December 7th was Sri Subramanya Sashti. So can AI identify this? What festivals like fall on what festival falls on December 7th? Then I also want to ask if it can get some of the festivals after December 7th, right? These are some practical issues like my like very frequently. My father actually used to goes and sees this calendar from time to time. So can AI help in these kind of scenarios? Let's see. It reasoned for a very long time, 1 minute 32 seconds. So it says I'm zoomed in the list of special functions at Shringeri shown on the calendar page. That is correct. So it does not list anything on December 7th. Oops. The entries from 6th to 8th, no special function. So it did think for a long time, but it just not able to get it. It says no festival on December 7th. That is wrong. So I'm going to ask what festivals are there after December 7th, right? Let's see if we can at least get this. So this one is even longer, like almost at the same time. Thought for 1 minute and 42 seconds. No event, it still says no event is listed on December 7th. And then after December 7th, let's see what it says. December 8th, it says Mangalarti, and December 10th, Sankashta Chaturthi, and so on. So it thought for so long, but basically got it completely wrong. So let me show why. So if you go back to the image, what it basically got is that this is December 7th, right? It's not able to get any of this. Gita Jayanti and so on. I don't really know where it got the other events from. Maybe the first I have no idea. Like even understand where it even got these from. So it's basically got it completely wrong. So yeah, despite thinking for 1 minute 42 seconds. That's very unfortunate. So coming back, let me move to the next challenge. So the next challenge is going to be from a conference poster that I recently attended, or my friend, a colleague presented in the conference. And this is very interesting because this is a poster, and what is interesting about this is that it's multimodal in nature because it has text, it has images, it has tables, it has graphs and other like blocks and so on. So it's a very interesting one. So let's see if how O3-mini-high works on these. this kind of an image. And it's also practically useful if AI can process this kind of information. So it's already done. Only 18 seconds, so it's able to get the title right. It summarizes a project using generative AI, and the authors are the poster. The authors are presenting a method to generate or alter satellite images in a targeted control manner. That is kind of great. Then introduction, motivation. It's able to like draw out the different sections. So explains why controlled image of satellite images is useful. Then the methodology, and then the results. It says targeted examples, image forensics, FID. So it's able to get FID, and more or less, yeah, it's able to get most of this things. And saying why it matters: control manipulation, being able to selectively add, remove, or modify features in satellite images can be very valuable for scenario planning, simulation, research. Yes, that is exactly what we wanted to convey in this paper, which my friend Chandrakant presented in ICPR in December 2024. So yeah, this is great. It did very well on this. So finally, we are here at the last challenge, challenge number 10. This is about like how it can explain graphs and charts, and this is from my own paper from way back in like 2000, I think 2012 maybe. The paper is titled Sarvam. So I'll just say explain this chart. So what is interesting about this chart is that, or graph, is that it has a scatter plot. It also has another like sorted plot, and the scatter plot and the sorted plot have kind of some amount of correlations, or this is like a design experiment which you would want to conduct to see like how you can put some designs on it. So meaning that I would have a threshold from here to here, from here to here, from here to here, and here to here, so on. So let's see what if it's able to get this. So this was pretty fast. It was able to only take 6 seconds. The figure shows a distance measure, red points, and the percentage of correct matches, blue curve. Yeah, that is correct. Oh wait, sort distance is blue, percentage of correct match is red. So I think it mixed that one, right? Blue curve is actually the sorted distance. Whoops. That's that's funny. So the distance, red dots. No, red dots is not the distance. Red dots are the percentage of correct matches. No. So it basically it switched the two. I think you switch red and blue. It's like maybe I'll say that for samples, blue curve shows how frequently the system made a correct match. So yeah, in other words, low distance values usually correspond to a high likelihood of correct match. So this is correct because possibly because due to the correlation, and high distance values, lower chance of correct match. This illustrates that the distance metric is a good indicator of correctness. So that is what we wanted to find, kind of check. If the sample's distance is small, it's more likely to be accurately matched. This, I'm going to say this is true, but I think you mixed red and blue. So let's see if it's able to pick it up from here. Reason for 1 minute 11 seconds. Let's clarify what each color corresponds to and how to read it correctly. X-axis index from 1 to 5,000. The samples are ordered, sorted by the distance measure from smallest distance to the left, and on the left to the largest distance on the right. Blue curve is sorted distance. Let's see if that's true. Yes, now it's able to get it. Blue curve is sorted distance. So after I kind of try to mention it, the line shows how distance grows from left to right. Perfect. Far left distance is very small. At the far right, distance is largest. So this is good. Red points, percentage of correct match. Each red point shows the correctness associated with the sample's distance. So yeah, this is also right. Why it makes sense. So this, I like it very much because this is exactly what we wanted to do in the experiment. Small distance corresponds to high percentage match. So it's also like that it arrows here. The distance between a query and its supposed match is small. The system is usually correct. Absolutely. You see that on the left side, large distance, low percentage match. On the right side, when the blue curve is higher, larger distance, the red points, meaning the match is more often than correct. Main takeaway, interesting. Even though the chart overlays two different y-axis and scales, brilliant. That's what I wanted to also say, that distance versus percentage, the overall trend is clear. Distance, blue line increases from left to right. Correctness, red point decreases from left to right. Hence, distance is a good indicator. The smaller the distance, the higher the likelihood of affecting. So I like this. I'm going to give it full in, even if it says, even though it got it mixed initially. So we are at the end of the 10 challenges. So it's been an interesting analysis of doing the 10 practical image challenges with OpenAI's ChatGPT o3-mini-high models. So what I would like to mention from the observations of these two experiments is that both the O3 model and the o3-mini-high are not yet good on images. So previously, these 10 practical image challenges I tried with the ChatGPT's O1 model and also the Gemini Flash thinking model, experimental thinking model, and both of them performed really well. And I was hoping the O3 Mini would even be better, but that did not happen. In fact, it performed in some cases very poorly than the other models, and it did not get any of the ones which the other models got it wrong. So, but what is interesting is that we have another reasoning model now. So I think as more time evolves, like we should probably get better reasoning and better image understanding from these models. So until next time.